This is a Goblin Teasmaid, arguably the archetypal automatic English beverage maker. It's a kind of glorified alarm clock, which instead of just waking you up with a raucous buzz, makes you a cuppa. You set up the kettle and the teapot the night before, and you put them on the table next to your bed, and come the programmed time, it boils the water, makes the tea, and then wakes you up with a raucous buzz. But how does it do that in the right order? What makes it tick? What programs the sequence? Is there a program, in fact? Well, this one's from 1976, and in 1976, programmable things were rare and specialised machines. They existed, there were programmable computers. Most people didn't have a computer, or in fact anything computerised in the home. But they did exist. Not in small appliances though. This is a combination of switches and solenoids and a heating element and a clock motor, and it just works the way it's been made to work because it can't do anything else. We would say that the functionality is hardwired in. So that means literally the wiring connecting each component to each other component governs how it behaves. Let's have a look at how it works and how you use it. Well, first of all, if it's going to make tea at a predetermined time, you have to dial the time in. I've set it to 6:30 there. Secondly, you have to put the right amount of water in the kettle. And when you put the kettle in place, you can possibly hear there's a click, and that's the switch telling the device that the kettle is full of water. You have to put the teapot in place, and then you switch it to auto. The lights go off, and if you've got the kettle and the teapot correctly set up, all is quiet. If you forget, for example, if you leave the teapot off, which could be rather nasty as it would probably soak you in boiling water, you get a warning buzz. Then, as the time advances, eventually it reaches the set time, and again you'll probably hear a faint click, which is the micro switch in the timer starting the process off. You can't see it now, but the kettle element is now on. And that will boil the water, and when it boils, steam pressure will siphon it through the spout into the teapot. You can probably just hear it starting to boil there. So at this point, the water in the kettle has started to boil, and the steam pressure is pumping it through the spout into the teapot. When the kettle water level drops to a critical point, the spring-loaded platform will pop up, the element turns off, and the buzzer sounds. That's the complete sequence of operations to make a cup of tea. The user sets up the teapot and kettle. The machine validates that the water is in the kettle and the teapot is present. The time is set, auto mode is selected, and then when the time switch operates, the element comes on, boils the water, it siphons into the teapot and the kettle pops up. The buzzer sounds, the lights come on, the element goes off, and then the user turns off the buzzer. Shortly we'll have a look at how that sequence is automated, what makes it happen in that order. But first, let's have a look at a different beverage making machine. Here's a beverage machine made about 40 years after the Teasmaid. It's similar but different. It makes coffee instead of tea, and it's not time controlled, but many of the functions are the same. It's got a boiler inside that heats the water as it comes through from the tank, and it pumps it, in this case through a coffee pod, into the cup, and it dispenses a certain amount of hot water and then switches off. How is it different inside? How is the concept of executing those functions different on account of the 40-year gap in technology? Now, I've actually taken the screws out already, and with any luck I should just be able to pop the cover off to reveal the workings. You can't actually see all that much. Down here is the boiler. There's a pump, which is basically a vibrating solenoid, and you can see various hoses for the water to flow through and various wiring. Conceptually, one of the biggest differences between this unit and the Teasmaid is to be found up here. If I prise open the back cover and unplug the ribbon cable from the control buttons, I can extract this module. It's quite difficult to get it out of the machine, but you can see that there is this self-contained module here with various wires going to different parts of the machine. There are leads coming down here to the pump and the boiler, and there's a temperature sensor, and obviously the control buttons and their indicators, and the main power input. And they all lead to this central control module that programs the operation of the machine. Everything from what temperature the water needs to be before it'll make coffee, to the length of time the pump runs, to how fast the indicators in the buttons flash. Everything is coordinated from within that module. These days, many appliances and devices are controlled by a microcontroller, which is a tiny computer on a single chip usually, programmed to do all the functions of that specific device. So here, for example, we've got one of the first 35mm film cameras that was controlled by a computer, as they advertised it at the time. We've got my trusty multimeter. This central heating programmer makes a very good example to reveal what's inside a typical microcontroller-based device. The user interface consists of various buttons and switches and the LCD display. And then, if we take the back off, we see a couple of relays on the circuit board that constitute the output by which this controls the heating. That chip there is the central brain of the device, if we can call it that, on which all the functionality is operating programmatically. So the code was written to make this thing behave the way the manufacturers wanted it to behave. Here's the chip, it's all in there. That is the brain, if you like, of the unit. All the functions, everything from how the display flashes when you program it wrongly, to how long it takes to select a function by holding the button, to the order in which it'll allow you to select heating and hot water, all of those functions are decided programmatically by the code that's running in that little microcontroller. The hardware in this central heating programmer is all geared up to being just a central heating programmer. But exactly how it behaves depends not only on the hardware, but on the program. If the manufacturers put a different program in the chip, it'll behave differently. The same is true of pretty much everything. This camera could have some different exposure functionality, for example, with a different program. In fact, some devices, this series of multimeters included, exist in different model levels, and the more advanced models run a more advanced program that makes more use of the hardware. How does that compare with the Teasmaid? That doesn't run a program. The 1980s and 90s were the decades in which electronic and computerized controls started to become standard in domestic appliances and equipment generally. Prior to that, controls were typically electromechanical, so you had moving wheels and cams and gears, pushing micro switches, switching things on and off. And by the turn of the century, it was all in the mysterious little black box or inside a chip and working programmatically. This is an electronics magazine, hobby magazine from 1981, that carries adverts for various innovations, and one of the ones that we can see here is a washing machine, which is described as a microprocessor-controlled Credo washing machine claimed to be the world's most sophisticated. And we see a picture of the machine with lots of buttons on the front, and this was the era of having lots of buttons and indicator lights. And the functionality that they're boasting about is just the microprocessor control. They're not saying it washes the clothes better, or that it uses less energy or less water or less detergent. The feature is specifically that it's got a sophisticated computer-age brain driving it, and presumably that way justifying what was probably a much higher price for basically the same washing machine, just with a different control system. As we've seen, the Teasmaid doesn't have a central control module. It certainly doesn't have a microcontroller running a program on a silicon chip. So how does it get things in the right order? How does it know how to behave? Well, let's have a look at the parts and how they're connected together. First of all, and central to the whole operation, is the kettle. That's just a regular electric kettle with a power input to the element that plugs into this flex here from the main unit. The teapot is just that, it's a teapot, it's not electric. If we look at where they stand on the base, the kettle operates this spring-loaded platform, and that's controlled by an adjustable spring to pop up when the weight of the kettle indicates that there's not enough water in it left for the element to heat. The teapot presses this plunger here. That's not really weight sensing, it's just detecting whether the teapot is there or not. If we have a look underneath, we can see over here the contact operated by the teapot, and over here the contact operated by the kettle. Down here are the two lamp holders, and we've got terminals for the power coming in and the output to the kettle. And that's it. There's nothing else under there. Having a look in the back here, we've got the timer. There's the motor that drives the clock hands, and hidden away down inside here there are a pair of contacts that close when the set time is reached. Over here we've got the function selector switch that has 4 positions: off, light, auto, which means time controlled, and T now, which bypasses the timer and energises the kettle. And the last part of the story is the buzzer that's supposed to wake you up when everything's done. That's just a vibrator. It's a coil that buzzes an armature at 50 Hertz, the frequency of the power. And that's it. There is no coordinating element. The way it behaves is a function of how those components are interconnected. We say the behaviour is hardwired in. It's not programmable, you can't change it in software. The very construction of the machine and the choices of which contact feeds which other contact determine how it behaves. So for example, when it's armed, when you set auto mode and you haven't put the teapot in place, this black wire becomes live, this contact is in the up position, that energises the yellow wire which operates the buzzer and the light. If you have put the teapot in place, that circuit isn't made and it waits for the time switch to close its contact, and then this white wire becomes live. First of all, the kettle is in the down position because it's full of water, and that energises the red wire which powers the element. Then when the kettle gets lighter because the water's siphoned out into the teapot, that energises the yellow wire as the contacts change over, and once again it operates the buzzer and the light. If there is any kind of nerve sender, I suppose you could call it the switch, which selects whether the T now wire is live or whether the auto wire is live feeding through the programmer contact, or whether it simply energises the light directly down the yellow lead. But that is it. It will behave the way it behaves because of how it's made. If you wanted to upgrade it to be a different or better Teasmaid, you'd have to change the hardware. You couldn't change the code, you couldn't software patch it, you couldn't give it an upgrade over the internet. It's just how it is. And that was how so many appliances of its day worked. They were hardwired to behave in sometimes quite complex manners, but it was a function of the physical construction and not the programming that made them the way they were.
Nailed that, I think.
Yeah, I think so.
Yeah.
Can I do it once for safety? Or have we not got...
No, we're fine. We've got...
Yeah, I think we've got enough to go through everything, yeah.
We've got 2 hours. We're doing fine for battery and stuff.
Okay.
All I'd say is, let me restart, because that was such a good take. I don't want it to get lost in the...
In a way, it's like an electrical version of the mechanical automata that were popular in the 18th and 19th centuries. Beautifully made pieces of clockwork that could carry out surprisingly intricate and complex tasks. But they weren't interactive. They did what they'd been programmed to do in a formulaic way. And the same with this. It carries out a sequence of operations that's intrinsic in the way it's made. You couldn't reprogram it to behave differently. In the Teasmaid, we've got hardwired combinational logic. If the time is right, and the teapot is present, and the kettle is heavy, then boil. But if the kettle is not heavy, then buzz. In the coffee maker, well, we'll never really know what kind of program that's running. It's all hidden away inside the microcontroller. But ultimately, it's just a different means to the same end, coordinating a heating element and some water siphoning. But with about 40 years technological development between the two. The next time you operate some kind of automatic or semi-automatic device, you might like to wonder, where is the intelligence? Where is the programmability? Does it have any? What's making it behave the way it behaves?